Alright guys, we are here and we are back, and we are here for another official chapter in Programming in Basic on the Tandy Radio Shack TRS-80 color computer, also known as the CoCo. We're on chapter 22, Get Input, and this is a really important chapter when it comes to doing game stuff. And a lot of things have been going on behind the scenes leading up to this chapter. You know, some of the behind the scenes stuff was I wanted to finish my little fonts project before I started this chapter. Fonts project is done. I'm showing you the fonts demo.
Hi, I'm Alan Huffman of Subbeat the Software. I won an award and I have a cool shirt. And you're watching the original gamer do old stuff.
So let's jump in without any further ado and let's look at the chapter. Let's read what the chapter has to say. We'll go through the examples. I've already done all the examples and saved them as separate little programs on my disk here, so I don't have to type them in, so the video will go a little bit quicker too. So this chapter is chapter 22, Get Input, the display that went array. Alright, in previous chapters you have learned a few ways to move figures from one screen to another, but none is very efficient. Have no fear. There is a better array grown. It has to do with get and put. Using these statements, you can get a rectangular area from the screen, store its contents in an array, which is an area of memory, and then put it back anywhere you want on the screen. This is the best method for simulating motion. Get and put is essentially like a copy and paste for graphics. You can copy a block of graphical information that's already on the screen, draw some graphics, put some graphics there, copy it into memory, and then you can paste it somewhere else on the screen, kind of like a rubber stamp. And so this is how we can move objects across the screen. This is how we can do animation. This is how we can simulate sprites, you name it. So here on the little sidebar here it says a who, a what? Arrays are covered in part 3 later in this manual. We'll use the term rectangle to refer to an area that contains the graphic display. Of course, you can't actually see the rectangle. You'll have to visualize it. Here's an illustration to help you. Will it help us? I don't know. So here's the book's explanation. So we say get h1, v1 through h2, v2, array, g. What does this mean? We get the rectangle on the current graphics screen and we store it in an array. h1, v1 is the top left-hand corner. h2, v2 would be the bottom right-hand corner. And so you draw an imaginary box around this with x and y coordinates on the screen. Everything that's in that box will be stored in the array that you set up. G stores the array in full graphic detail. This is required when using high resolution mode 3 or more mode 4 color options. Now there's something funny about the G command, because when you get it with G, it does store all the graphics array, but when you go to put it, it actually causes it to put slower because it's doing a more bit by bit memory translation. So there are ways to hack how you get and put things and not use the G thing, which I'm not going to get into too much right now. But if you're able to get things that work out to be perfectly 8 pixels or 1 byte, and everything you get is 8 pixels of monochrome or 4 pixels of color, if you can get things in even 1 byte increments, and you can put them at 1 byte increments, you can bypass having to use the G option, and so it would make getting and putting faster, but you have to know where things are and how big they are and where you're putting them. So there are ways to hack this to make it faster, which I'm not going to do. And so you'll see here the normal way of doing this gets to be kind of slow. So once we've gotten this, once we use get to get the square picture or the rectangle picture, then we can use put to put it on the screen. And so we put it, again, we have to specify the starting and ending position, which is kind of silly. You really shouldn't have to specify the ending position. Once you've gotten something, it should know how big it is. And I don't think you can bypass that. So then you basically say, well, where do I want to put this? So we'll put it, if I get it from the top left, I'll put it in the bottom right. So you just give it new coordinates where I want to put it, and then you have to specify this top left corner, bottom right hand corner, the name of the array, which is basically what you copied where you want to paste it, and then there are a series of actions which you can modify how you paste this or put this on the screen. It does say be sure your computer is in the same P mode for get as it is for put, or otherwise you might not put what you got. Alright, well, we'll we'll explore some of that. So here's the first example.
Hi, my name is Brendan Donahue, and you're watching the original gamer Stevie Stroh.
It says type and run this program to see how get and put work. So we're going to clear the screen. We're going to draw a circle. We're going to get the circle. We're going to clear the screen. We're going to move the circle somewhere else. There's our first exercise. There it is. Top left, move to bottom right. So we drew a circle, we got it, we moved it over. That's what get and put does. Let's do this one more time just so you can see it. Okay, circle's in the top left, circle moved kind of like a lower center. So we got it from one space, we put it in another. That's what get and put does for us. Very cool stuff, right? So that was our first example, and then it goes through and explains it. It says, okay, well, we created an array named V. An array, the array V is big enough to store a 20 by 20 rectangle. According to this, they're telling you that this number needs to match the number of pixels you're going to grab. We drew the circle. We get a 20 by 20 rectangle containing the circle, and we store it in the array called V. We clear the screen, and then we put it further down on the screen. So as you can see from the above program, get and put uses an array to store the rectangle. So before you use get and put, you need to create this array. We have to use the dim statement to dim the array to kind of specify it and do it. The dim array, the array is the variable you want to assign to it. In this case here it was V, and then the length and the width of how many pixels. It says dim should be one of the first lines of your program after clear and pclear if you use them. Over here it says how large a rectangle you can store in an array depends on how much memory you have. Each point when stored in an array consumes 5 bytes of memory. In a 16K RAM system, you can store no more than 1,400 points in an array. If your program is long, you may have to use a smaller array. So I'm not sure how that math works out there. I'm not even going to try to figure it out, but they're saying that each point, meaning each pixel, takes up 5 bytes of memory. That's crazy. That's crazy talk. All right, so we're going to dim an array. That dim statement should be high up towards the top of your program. We use that to reserve space and memory to store the pixels, the grid of the pixels. How large does your array need to be? It depends on how large your rectangle you want to get and put. So your width should be your second height minus your first height. That is your width. Your length, oh, H, when I say H is horizontal. Sorry about that. Horizontal, X. So what is your width? Take your second X coordinate, the one that's bigger, subtract it from your first one. The distance is your width. Same thing with your vertical or your Y. Take your lower pixel, subtract it from your higher pixel. That's the difference. That's the width and that's the length of your square. In this example, the get put statement uses 10 by 10 as the coordinates and 30 by 30 as the ending, so the difference is 20. The rectangle is 20 by 20. It has a width of length of 20. The put statement uses the same rectangle size of 20 by 20, but it's not always going to be that, right? So now we're going to get into some of the different ways to put things on the screen. It says put not what you see. Now you've seen a rectangle on the screen one way using the PSET action. Why don't we specify so it says if you don't specify the action, it automatically uses PSET. But it says there's more than one way to do it. And so now, this is the new program. This is the program that actually didn't work. Okay, so this is the one I had to mess with. So let's look at everything that's wrong with this program. Okay, first thing that's wrong with this program is they set to a P mode 2, which is a monochrome mode. Yet over here they have us painting in 2 different colors. They have us painting in color 2 and painting in color 3. These colors would not exist in a P mode 2. So that was one of your first issues. And we're also painting kind of only a couple of pixels away from each other vertically, and so the paint would have basically overlapped itself. So that was also another issue. We were setting a mode that didn't support color. We're specifying 2 colors in basically the same space. And then when we got into the actual math of drawing the circle and getting this circle, whatever the numbers were, they kind of didn't quite work, because when you finally ran through this program here, and what this program is doing is it's drawing a circle and then it's having the circle kind of move across the screen in a diagonal line, it just didn't work right. The circle was all garbled and stuff like that. And so I thought that there was something wrong with my computer because I was running VCC. I was trying to figure out what the problem was. It turns out the problem was the program. So let's look at what this program is supposed to look like.
This is Brett Gordon from CoCo Fest 2017. Please watch the Original Gamer Stevie Stroh's YouTube channel. It's excellent.
So this is now the second demonstration, which is called Get Put To. So when I load Get Put To, and hopefully my computer's memory, hopefully my CoCo is not going to be out of memory. Okay, this is what I did. Number one, because it was trying to paint in two colors, and it was painted two colors at pretty much the same spot where the colors would have wiped each other out, I actually drew a line in the middle of the circle and I moved the coordinates over so the two colors would show on the two halves of the thing. So when we run this program again, you'll see that the circle gets painted in the center of the screen, and then we start moving it down at an angle. And you see it's kind of choppy, but you see how it's basically erasing itself too. Another thing I had to do, this is my modified code. So in my modified code, I am getting from 9971, 10 pixels different than the book says, to 159, 121. So yeah, there was a huge difference in the area I had to get to capture this whole circle. The coordinates in the book were just whack. So also when we started moving our I coordinate to the left, it had us doing a -10, and moving -10 was like moving it where there's like little pieces of the circle were being kind of stripped and like leaving crumbs across the screen. So I kind of tweaked it and stuff. So this is the code right now. And so what the code is doing is it's basically, we started off, we cleared the screen, we drew a circle. This is me drawing a line in the middle of the circle. Now this is me painting on each side of that line, moving the X coordinate over a couple pixels to paint one color, moving the X coordinate over a couple more pixels to the right to paint the other color. This is the command here to get the thing into a variable G. A variable is V, and then the G is graphic detail option. So whenever you do G, it means get all the detail, which is more accurate but slower. We then clear the screen, and then we say we're going to start at 150 and work our way to 1. And so we're basically starting at a position around here on the screen, and then we're moving our way back this way. And so we're using I as our X coordinate, or our horizontal axis. And so we go here, and then we are then also taking this number here, dividing it by 5, and then we're subtracting that from some numbers here. And so what ends up happening is as X is changing, the vertical position is also changing. So as we're moving further to the left, we're also moving further down. So it's allowing us to kind of go in this diagonal direction. And we're using the option here called PSET. PSET will put exactly what it gets pixel by pixel. It's a bitmap perfect stamp of what you captured, and it erases everything behind it, and then we continue the cycle. So we'll run this one more time. And here it is. And now we're moving to the left, and we're moving down because we're taking that I number and we're dealing with that number and adding that and somehow manipulating our vertical axis as well as our horizontal axis. So we created the illusion of a circle kind of sliding downhill. That's what this little program did for us.
Hey, this is Bruce Moore, author of Force of Doom, and you're watching the Original Gamer Stevie Stroh.
But now, here's what it's asking us to do. It's asking us to change line 60 now, and instead of PSET, it's wanting us to use preset. And then let's do a preset. And let's run it again. And so that's my first circle, but now look at this. Now it is a reverse circle. So by doing the preset, I'm actually doing an opposite mask to all of my bits, to all of my colors. So what was black was white, what was white was black, and when it comes with the other colors, they kind of get flip-flops. So it used to be the area around the circle was white, and white is technically color 0 or color 1, the low bit, and orange is the high bit, which is the all bits are on. And so the opposite of this is like the opposite of black and white. It was white, or was black. When it was white, it was kind of like black, that's the low color. Orange is kind of like white, that's the high color. It got completely reversed. And then these two colors here kind of got reversed too from what they were. So the preset takes whatever you got and it pastes it basically kind of like a negative image, negative colors of what you had. So the next thing it wants us to modify now is to change it from preset to OR. So if we modify line 60 and we change it from preset to OR and we run it again, let's look at it. And now what we're doing is we're kind of pasting on top of ourselves, and we're not necessarily erasing the background, we're not destroying everything. We are pasting ourselves and we're ignoring low colors. So in this case here, the white color is a low color, so the low bits are ignored and they're not pasted, so they become kind of like a transparent mask. And so anything that was black, or in this case white, whenever the low color was, that is ignored. And anything that's higher than white, so white is color 1, you have color 2, color 3, color 4, any of the higher number colors will automatically overwrite white, and white will automatically ignore any other colors, so it becomes kind of transparent. So with the OR option is kind of interesting, and you can see here that it just did an interesting effect here.
Between 1977 and 1994, Tandy and Radio Shack produced a wide array of prolific personal and business computers. Chances are you've used one. And now there's a new event designed to celebrate all of these computers in one place. Introducing Tandy Assembly. Come see your favorite computers, or maybe some that you missed. October 7th and 8th. In Ohio's first capital city, Chillicothe. See presentations by TRS-80 creator Don French. Creator of Dog Star Adventure, Lance Miklas. And Scott Adams of Adventure International. For details, visit our webpage at www.tandyassembly.com. Some assembly is required.
The next one it wants us to try is an option called AND. So if we now edit line 60 and we change this to and we run it, that was my original circle. I don't even see the circle. For a strange effect, try the not action. And the not action is doing nothing. Not sets the reverse and the reverse of what's on the screen. Not doesn't care what's stored in the array. Each rectangle puts on the screen is the reverse of the previous one. So not just says, screw you guys, I'm going to erase whatever's on the screen. And so not is not really helpful, because it says and compares each point in the array rectangle with the screen rectangle. If both are set, the computer sets the point. So and is only going to put the parts of the picture that match other pictures that are already on the screen, and if your screen is blank, there's nothing it's going to do. So and has to be a kind of a cumulative of positive integers, and there are none here right now. What is OR? Let's do OR. When we do it with an OR, so OR is kind of like an interesting way of pasting, where we're pasting all the colors that are greater than 0, all the colors that are that are on and not our background color. So anything that's not a background color, any foreground color will automatically get pasted, and we ignore the background colors so we can kind of have some transparency here. And then we have one that's called not, and if I do not and I run it, then I am seeing kind of this entirely reversed square, where it's reversing the square each time it goes through. It says not reverses the state of each point in the screen rectangle regardless of the rectangle's contents. So not does not care what you got. Not will just reverse whatever's on the screen where you put this not. So I'm having a hard time finding a good example of that being useful, but apparently it is.
Hello, this is David Ladd, and you're watching Original Gamer Stevie Stroh.
Alright, so this was the example in the book. And the example in the book basically took the stupid little freaking circle thing that it drew, and it tried to have you run this little circle demo, manually changing the different options to illustrate how get and put works. And so I thought, okay, that's kind of cool, but as you see me here kind of stumbling through this and having to edit the program each time and make a change each time and not being able to fully visualize the benefits of this, I said, well, there's got to be a better way.
I'm Evan Wright, author of Flooded for the Color Computer, and you're listening to Original Gamer Steve Stroh.
So I came up with a better version of this demo that's going to show us all the various versions. So now that new demo, which I've been working on for a while and I've been blogging about it a little bit, so it is on my blog. This is now Get Put 3.
Hi, it's Glenn Hewlett. I'm here at the CoCo Fest 2017, and you're watching Original Gamer Stevie Stroh.
This is a completely original custom demo that is a better version of what the book just tried to show us. I'm going to show you how to put things different ways, but I'm also going to show you how it affects how different colors on the foreground are affected by different colors on the background. And I also incorporated my fonts demo, and we'll see how all this goes. Now hopefully I won't run out of memory and get one of these UL errors. Okay, so here are my circles, and I actually drew little boxes around the circles here so you can see that I got them. So I've gotten a red circle, a blue circle, a yellow circle, and then a reversed green circle. These are the circles I created. The little boxes here are for your visual indication to know this is the array I'm going to capture, and I basically got just inside there with my get commands. Now we're going to pause. Now I am creating color bars in the background. So as we paste across the screen, when we see these different options, some of these options only are effective when there's another color already there and it compares the different colors. So now I've created this color bar here that we're going to use to continuously refresh our screen. And so now we're going to put using the PSET option. And here we go. This is what it's like when we PSET. When we PSET, it automatically erases everything on the screen behind the array where I got it. So PSET is an absolute paste, and it does not mask out any of the colors. If there was a blank color there, the blank color gets pasted and automatically erases what was behind it. So that was a PSET. That's the normal way we paste. That's the normal way we put.
Hello, my name is Grant Leedy, and I watch the Original Gamer Stevie Stroh.
Here's the preset. The preset is the exact opposite of that now. It reverses the bits. It reverses the color. It's a negative image of what you got. So when I paste this now in a preset, you notice that that inverted circle I drew that was green on red is now red on green, and everything else that was on a green background is now on a red background. It got reversed. That is the preset.
Hi, this is John Robbs. I'm at the CoCo Fest here with Steve Strobridge, the Original Gamer, and we're having a great time geeking out on 30-year-old hardware. Having fun.
Now we're going to do an and an and somehow combines things based on the color of what you got and the color of the background. Let's see what and looks like. Okay, so with and, we don't see it on a blank background, but we do see it on a color background, right? And so when we put things against color, we can kind of see these color masks. Pretty interesting, right?
Hey, this is John Strong. Bleep, bleep, bleep. Blooper time. You're watching the Original Gamer Stevie Stroh.
Now we're going to do or. Or is kind of like the nice pasting of things and kind of combining things, but it leaves the transparent colors and doesn't paste anything transparent. So this is or. And so here's my or colors. You will see them move in front of some colors and not in front of others. This has to do with how bits combine, how colors combine. And or is pretty cool because or is the closest thing we have that's kind of like a sprite with a translucent background.
Hi, I'm Mark Barlett with Sandy Weimer. We're from Cloud9, and you're watching the Original Gamer Stevie Stroh.
And then here's not. And not is like, dude, I don't care what you got in the past. I'm going to put the exact opposite of what's on this screen whatever that case may be. So I'm just going to reverse the bits of what's on the screen and put the opposite color. So not doesn't maintain the shape, it just reverses the background, which is an interesting effect if that's what you're going for. If you just want to screw with the background, like if you like right now where I have press any key, I could put that as a knot and just keep putting that down there, and that would make the press any key kind of flash in reverse. That might be an interesting effect.
Hi, I'm Max Jackson here at CoCo Fest, and you're watching the original gamer, Stevie Stroh.
That might be why you want to use that, but for doing it in the form of a sprite, I don't see much use here. But what I did here is I tried to give you a better visualization of that, the in-book demo, showing you these options using multiple colors against multiple color backgrounds so you can see it. So let's run through it one more time.
Hi, I'm Mike Rowan, and you're watching the original gamer, Stevie Stroh. And when you're done watching, come over and listen to the CoCo Crew podcast.
I also included my fonts because I have them, right? So this was the PSET option again. Here we go. PSET is going to put things, every pixel, every bit will be pasted literally, whether it's on or off. All the blank colors will be pasted and they'll erase the background behind them as well. Right, so here's PSET. This is a normal put. If you don't specify anything, this is how puts get put.
Hi, this is Randy Weaver, and you're watching the original gamer, Stevie Stroh.
There we go. That was PSET. Now let's look at preset, which is the negative image. Completely reverses all of the bits.
Hello, I'm Richard Chrislip, and I'm coming to you via the original gamer Stevie Stroh's program.
Alright, now let's do the and. And is kind of cool. And does kind of a reverse mask, but only based on the color that it touches. You won't see it on a blank background. You'll see it on certain colors. Pretty interesting. I love that ghost circle, that ghost green circle.
Hi, I'm Randy Weaver, and you're watching original gamer Stevie Stroh.
Here's the or. The or is my favorite. Or kind of combines things but leaves the clear background alone. Or is very close to how a sprite would work, but you have problems overlaying colors. When you put in certain colors on top of other colors, they either change or get lost.
Hi, this is Rick Adams, and I'm the author of Temple of Ram and Shanghai, and you are watching original gamer Stevie Stroh.
Okay. And then knots like screw you background, I'm just gonna reverse you. The knot just reverses the background. And there it is. So this is my demo, and this demo I was working on for a while. It's not completely amazing, it's not overwhelming, but it took me a while to work out the stuff in my head and just have the time to type it all out, because there's no easy way to copy and paste things. I also used some trickeries because I'm using some P copies, so I'm restoring the background as I'm moving through here, so I have some sound to pause it. So it's kind of a cool little example on cheesy animation, and I will make this disk image available on my blog, so you can go to my website and check out the blog post for the Get and Put chapter, and you can download the disk image if you want to look at the code and mess with the code and do some more things with it. Hey, what's going on, everybody? It's me, it's Original Gamer Stevie Stroh, and I just want to let you know that I have merchandise available at my website right down here called ogsteviestroh.com. What kind of merchandise do I have? Well, you can get yourself a DVD kind of like this. This here's my DVD from 2016. This is the CoCo Fest 25th anniversary color computer gaming DVD. What else can you get on that website? Well, you can get yourself a DVD like this. This here's my brand new DVD for 2017. This is my CoCo Fest 26th anniversary DVD featuring 13 gameplay videos and over 3 hours of, or at least maybe 2 hours of, you know, gameplay goodness. Well, for a limited time anyways too, you can get yourself the 2017 version of Pop Star Pilot on my website by going to ogstevestroh.com. And this is the new edition that will be available for sale this year at CoCo Fest in April of 2017. You could get yourself one of these here, right here too, from my website, ogstevestroh.com. And you can also get yourself a really cool retro swag shirt like this that says Original Gamer. You can get the insert coin logo. You can get the I'm a Coco Nut. You can get some Atari 2600. You can get all kinds of retro images on a t-shirt or a coffee mug. It's all good stuff and it's great merchandise, and I'd really appreciate it if you go to my website right here, ogstevestroh.com. Click on the link for merchandise. Check out what we got. Get yourself some today. All right, people. The last thing the book asked us to do, and I got a little bit fancy with it, is it gave us a do-it-yourself chapter, a do-it-yourself program. It says use get and put to send a spaceship up the screen and across its outer limits. You might want to add a few asteroids and aliens to make your voyage more exciting. So it's wanting us to use get and put to simulate a rocket ship flying off our screen, right? So I did a cheesy little program that does that. So let's load get put 4, and we're going to end this video, and we're going to call it a chapter. Get and put is good times, and I did some kind of cool trickery in here too. So what's the first thing we do? I draw a cheesy spaceship, I draw some colorful planets, and then there's my spaceship. You can't really see the spaceship for a minute there because it was behind the planet here. So what I did here for some trickeries is I started off in P mode 4 when I drew my spaceship, so that's my high resolution graphics there, which are beautiful artifacting. Then I switched to P mode 3. I drew some random colored planets because P mode 3 will draw on P mode 4, give me the colors that P mode 4 doesn't understand. The P mode 4 screen is still the active screen, so now I see these artifact colors. And then I take my spaceship and I'm getting and putting him on the screen. So the vertical resolution is just a 4 next loop. I start you know, very on the bottom of the screen, and I work my way to the top, and so it's just a 4 next loop. The X coordinate is just kind of randomized, and so every time it loops and it starts over, I'll move to a new spot on the screen. And once in a blue moon, you have a chance of this thing actually redrawing the planets again like this. And so every now and then it'll do a quick decision when it loops over and says, okay, well, do I want to redraw the screen? So how am I doing this right now? Well, this is some software trickery. This is how we kind of do sprites in BASIC. You need 2 screens to do this with, or 2 pages, I should say. And so on my back page, I have copied all of the planets, and they are there. As I'm getting ready to put my spaceship, I get the background into a different array. So I get what's behind it. I put the spaceship there, which now superimposes him on the foreground with the OR option, so it's kind of superimposed. I then p-copy that to the visible page that you can see, and then I put or replace the background that was there, and then I continue my way through here. But on the page you can't see, you're going to see some flickering of the ship being pasted and erased and pasted and erased. And so to not allow you to see that flickering, I do it on a different page, and I only copy you the page once all the dirty work is done. This is what a lot of people call double buffering, right, which slows things down too. And so you can see the animation here is pretty herky-jerky. If I had to, I'm doing it like, I think I'm doing it 4 pixel increments or something like that, so it's not, it doesn't appear to be as slow, but it looks a little jerky, right? And so this is one of the downsides of trying to make a game in BASIC, is that it's slow. But this is animation. This is moving an object on the screen. This is moving a character across the screen. This is how we can do sprites in BASIC. We can get and we can put. And so it's an important concept to kind of grasp, and I don't know if I did it any much of a better job explaining it than the chapter did. I just felt the chapter was very short. And I think it's just what I did with get and put as a kid was much more elaborate than how the book tells us what to do with it. It's just when your mind starts running, you start coming up with ideas. So I did a lot of stuff with get and put that the chapter just really, I felt like the chapter just did not do this these commands a lot of justice.
This is Ben and you're watching OG Gamer Stevie Stroh.
So I'm hoping that some of these demos here that I'm showing you will help you understand what to do with get and put, and I'm also combining some things we learned earlier in the book, which is using things like pcopy and copying pages and switching modes. And so this is now pulling a few tricks out of the bag. But if you look at this program, the program's not that big. The program is, you know, let's list 10 through 40. Okay, so here's the first thing I do. I clear the screen, I set my P mode, I set my screen mode, I clear the screen. I make two dims. SP is for spaceship, BG is for background. I then use the draw statement to draw out my spaceship, and there he is. And then I get my spaceship, and he's a 40 by 40 grid of pixels. These are the coordinates here on line 30 where I'm getting my spaceship. I then, in line 40, I set the P mode, I set the screen mode, I clear the screen, and now I'm getting ready to draw the planets on line 40. So when I list 41 through 50, okay, 41 now switches to P mode 3. This is kind of a hack. This is a little bit of a trick now. I'm switching to a different mode that supports color. Line 50 says, okay, I'm going to generate up to 9 planets. So let's list 40 through 60. All right, so I clear the screen, I switch to P mode 3, I pick a number between 1 and 9 for the number of planets, I pick a random X coordinate, a random Y coordinate, I pick a random radius, and I pick a random color. I pick a color between 1 and 3, and then I add 1 to it, because in P mode 3, color 1 would be the background color, which would be black, which I didn't want to see, so I'm picking one of the 3 foreground colors, so I'll get red, blue, or white. So then I create the circle and those coordinates based on that radius in that color. And then after I draw the circle, let's do 61 through 79. After I draw the circle, I paint it in. Line 70 then finishes the loop, switches back to P mode 4 because I was in P mode 3 before, switch back to P mode 4. Line 75 now does my P copy. Because there's actually 4 pages that make up a P mode 4 screen. I have to start at 1, 2, 3, 4, and then I have to copy them to 5, 6, 7, 8. So I have to copy those, and that's how I create my background. So now I have a whole separate page that's got a stock image, a stock copy of those planets I just generated. So now from line 76 through 89, let's look at that. These are my fancy animation tricks and page flipping. Let's list 81 through 99. So now what I do is the first thing on line 90 is I say P mode 4, 1, screen 1, 1. This sets the screen back on the top of my first page. I then go to P mode 4, 5, which takes me to my second page. Now here's where I set the random coordinate for where the X coordinate is going to be random, where my spaceship's going to be placed on the horizontal axis. And then line 95 says I'm going to start at line 151, which is towards the bottom of the screen. I'm going to work my way to the top, step -8. That's how it's jumping 8 pixels at a time. The first thing I do is I get my 40 by 40 grid of the background. Then I put the spaceship with the OR option, which is a kind of a masking that doesn't destroy the background. And then I have to do the P copy, and I have to copy the now composited image to the visible page that you can see. Once I've done that, then I have to put the background right back where I was, and then I continue my cycle as I continue to move up. So it's this kind of copy the background, paste the spaceship, copy that new picture over to what the people can see, put the background back, move up a line, and then repeat as necessary, and we go through the whole thing till I make it to the top of the screen. So and if I list the rest of the program, when I'm done doing that loop, and now it says, okay, I'm either going to go back to line 90, which continues to just scroll up randomly, and every now and then, if I pick the number 7, if I draw a number between 1 and 10, it's number 7, I'm going to go back to line 40. That's going to redraw all the planets. And so it's a real small program, and it's a real cheesy one, but I think it does a good job of demonstrating what get and put can do, what the different options can do, and how you can now apply some trickery and some of the tricks of the trade based on some of the other things that we've covered to start to see what it's like to make a game, to create computer animation, right? To do things like sprites, right? So could this be a video game? Well, it'd be a very slow, choppy, big, and bulky video game, but sure, it could be, right? So is this graphics and animation? Oh yes, 100%, right? So maybe not the greatest game in the world, but it's a kind of a cool graphics demo, right? So this is the Get and Put chapter. I just felt like this chapter deserved some time, deserved some consideration, and deserved some good visual examples on how Get and Put works, how to use Get and Put, what you can do with Get and Put. And I hope you enjoyed it. Like I mentioned before, you'll be able to download this floppy image from my blog. So if you go to ogsteviestrow.com, look for the Get and Put chapter. I'm starting to blog all these chapters. And when I don't have time to record it, I'm just making behind the scenes progress. I'm blogging that too. So if you need a little bit more basic, I will be posting blogs on a slightly more frequent basis than I'll be posting videos, because I don't always have time to record. So Get and Put, people. Spaceships, people, they're real. Aliens are real. All right, the government's been covering it up, but it's real. It's a thing. They're out there. The truth is out there. I'm the original gamer, Stevie Stroh. This is my color computer making a cool animated spaceship going through the screen. And I just feel like I'm 14 years old all over again, because I did this kind of cheesy crap back in the day. And it's cool. All right, guys, we're out of here. Thank you for watching. Keep on programming. Check out my YouTube videos, right? I got a lot of CoCo games. I've got 20 other chapters of me programming in BASIC. We've got interviews with people who make really good CoCo games. We've got our weekly CoCo talks where we talk about the color computer and things that are going on. Check out my website, ogsteviestrow.com. Maybe consider getting some merchandise. I've got DVDs of some of my gameplay videos. I've got t-shirts and coffee mugs and things like that. You just never know. There's always something for you on my website, ogsteviestrow. Check it out, and we'll see you on the next video. Peace out, everybody, and bye-bye now. CoCo forever.